Hello everyone. Okay, so in this video we are looking at quadratic inequalities. So from Gene Cert you should remember linear inequalities. Now we're going to take a one step further in Leaving Cert and we're going to look at quadratic linear equalities. So what is a quadratic linear equality? Well, it is an equality that looks like this. I have a quadratic to one side and it's going to be greater than or less than 0 or some number. So how do I solve these quadratic inequalities? First, I need to solve the quadratic and find its roots. You then draw a sketch of the function or the quadratic, you marking where the roots are. Then you're going to use your graph to identify if I'm looking above or below the x-axis, and we find the values of x that satisfy this. Again, no point me telling you what to do, better off just doing it. So find the solution set of the following. X squared plus x minus 12 is less than or equal to 0. So, first step is we solve it. So it's going to be x squared plus x minus 12 equals 0. So two numbers that multiply to get minus 12 but add to get 1. That is going to be my plus 4 and minus 3. Solve them both. I get x is equal to minus 4 and I'm going to get x is equal to positive 3. Done. Second step, sketch it out. Right, this has to be a rough sketch. Draw something like this, labeling your 2 points. Now, it's important which point you label. So, I have x is minus 4 and x is 3. So, my leftmost root will be my smallest root, or the lesser of the two. So, in this case, my leftmost root is going to be minus 4, and in this case, my rightmost root is going to be 3. Now, I go back to my initial inequality. So, I have my quadratic is less than or equal to 0. So, we are being asked now to list the range of values where my quadratic is less than 0. If it's less than 0, it means we are looking for the values that are beneath, right? Beneath the x-axis, right? Because when we say the quadratic is less than 0, we just mean the y, or the output of my function is less than 0. And we see here, right, between these values here, this is where my function is below the x-axis. So I'm going to label this blue just for like the ocean, deep ocean, right? Like the ocean goes underneath. So I want to find out the range of values between minus 4 and 3 that trap these values. Well, as you see here, so I'm going to the right, and then I'm stopped by the 3. So I'm going to have minus 4 is going to be less than or equal to x. So x here has to be greater than or equal to minus 4. Fair enough. But I have a condition. My x has to be less than or equal to 3. And that's it. That's how we solve a quadratic inequality. So you just have to remember, if it's less than 0, we're looking beneath the x-axis. If it's greater than 0, we're looking above the x-axis. So I'm going to do an example of looking from above now. Find the solution set of the inequality 6x squared minus 3x minus 18 is greater than 0. So I have greater than 0 here. So that is going to be above x-axis. So 6x squared minus 3x minus 18 equals 0. So I need to solve it first. Well, I notice here I can divide across by 3. So I have 2x squared minus x minus 6 equals 0. 2x here, bing bong, x here, and this is going to be minus 2, and it's going to be plus 3 equals 0. Solve it out. So I'm going to have 2x plus 3 equals 0. X minus 2 equals 0. X is equal to 2. 2x is equal to minus 3 over 2. Gorge. Now we sketch. Again, we're just sketching my quadratic like this. So minus 3 over 2 is my lesser one, so that's going to be my leftmost one. 2 is my bigger one, so that's going to be my rightmost one. So this here is going to be minus 3 over 2. This is going to be 2. I am looking for where it's greater than 0. So all divides my quadratic where it's above the x-axis. And you see, it's above the x-axis from these range of values here and these range of values here. So how do I get this green shaded region? Well, x has to be less than minus 3 over 2. And how do I get these green values here? Well, x has to be greater than 2. And that's it. And notice how I kept the inequality sign that's given up here. If this was greater than, if this is just a this is just a normal greater than, if this is just a normal inequality sign. If it was a less than or equal to, like it was up here, then you use the less than or equal to sign. And that is how we solve a quadratic inequality. Easy peasy, lemon squeezy. So let's look at some exam papers here. Don't get your hopes up because there's not that many. Right, so this is from the 2013 Leaving Cert paper. So this is paper 1, question 2. Find the set of real values of x for which 2x squared plus x minus 15 is greater than or equal to 0. So first thing I notice, greater than or equal to 0, that is going to be above x-axis. Right, it's going to be above the x-axis. So solve. 2x squared plus x minus 15 equals 0. Factorize, bing bong. I'm going to have here x. That is going to be plus 3. This is going to be minus 5 equals 0. I'm going to have here 2x minus 5 equals 0. X plus 3 equals 0. 2x equals 5. X equals 5 over 2. X is equal to minus 3. So I have my two roots. So next step, I sketch it. There's my quadratic. Minus 3 is the smaller of the two. So that is my leftmost one here. 5 over 2 is my biggest one. So it's going to be over here. So I'm looking for the region that's above the x-axis. So I'm looking for this region and this region. And how do I get them regions? Well, x is going to be less than minus 3. And x is going to be greater than 5 over 2. Right? So remember, if it's like less than or equal to 0, it's one of them compound inequalities. Right? If it's less than or equal to 0, it's one of them compound inequalities that looks like this. It's one straight line. If it's greater than 0, it's going to be open. Right? It won't be a compound one. It won't look like that. Here's another one. This is from the 2008 paper, Leaving Cert higher level, paper 1, question 5. Find the range of values of x that satisfy the inequality x squared minus 3x minus 10 is less than or equal to 0. Less than or equal to 0. So that means I'm looking for the values that are below x-axis. So x squared minus 3x minus 10 equals 0. Factorize and solve for the roots. So that's going to be minus 5 and x plus 2. So my answer is going to be minus 5, x minus 5 equals 0. X plus 2 equals 0. X is equal to 5. X is equal to minus 2. There are my two roots. Next step, plot it out. Yonk. Yoop. Minus 2 is the smallest of the two. So that's going to be my leftmost one here. And then 5 is going to be my rightmost one here. So I'm looking for the values that are below the x-axis. So I'm looking for these ones. So this is going to be trapped. This is going to be a compound inequality. So x is going to be equal to minus 2, greater than minus 2, but has to be less than or equal to 5. So minus 2 is less than or equal to x. But x is bounded on the right by 5. So x has to be less than or equal to 5. So greater than or equal to minus 2, less than or equal to 5. That's my answer. Bada boom, bada bing. Right? And the final one here I have here is this is from the 2004. This is from the Leaving Cert oil level paper. So p is a positive number. That seems very important. I'm going to highlight that. P is a positive number and f is the function. F of x equals 2x plus p, x minus p. Given that f of 2 is equal to 0, find the value of p. So f of 2 equals 0. So therefore, my input is 2. So I'm replacing x here with 2. So that's going to be 2 times 2 plus p. times 2 minus p equals 0. 4 plus p times 2 minus pi equals 0. I have two factors equal to 0, so I can just let them both equal 0. So 4 plus p equals 0. P is equal to minus 4, and 2 minus p equals 0. P is going to equal to 2. So looking back here, p is a positive. It's telling me right here p is a positive number. So therefore, it can't be minus 4. So glad I highlighted that. Right? Now, hence, remember, hence in mathematics means use the answer you just got, idiot. So, hence, find the range of values for x for which f of x is less than 0, for which the function is less than 0. So, p is equal to 2. We figured that out. P is equal to 2. So, I'm just going to sub it in here. 2x plus 2 times x minus 2 is less than 0. So, or equals to 0. We want to solve the roots. So, that's going to be 2x plus 2 equals 0. 2x equals minus 2. X is going to equal to minus 1. Here, x minus 2 equals 0. X is going to equal to positive 2. So, there are my two roots. So, sketch it out. My leftmost one is going to be minus 1. My rightmost root is going to be 2. I'm looking for less than 0. So less than 0 means below x-axis. So I'm looking for this region. And I get this region by, well, minus 1 is going to be less than or equal to x. But x is going to be less than or equal to... Oh, no! It's not less than or equal to. It's just less than, because there's no equal to sign in my original one. So, x is going to be greater than minus 1, but less than minus 2. And that's my final answer there. So, that's this video done. So, hopefully it was some help to you. So, next video we're going to be looking at rational inequalities, which is just this, but just one step above. And I hope this video was some help. And I'll catch you guys later. Bye-bye.